Hello friends, in this tutorial we will be learning about AC. In our previous chapter we have already learned about DC. DC means direct current and the meaning of AC is alternating current. Now, how can we identify whether a current is DC or AC? Whenever the current versus time or time versus current curve intersects the time axis, then it's an AC. And if the curve is not touching the time axis, it can fluctuate but it's not touching the time axis, then it's DC. So DC means it's an unique direction, it's not changing its direction. But in case of AC, it will alter its direction with respect to time. Now, the misconception about AC is AC should be always like this. But AC can also like triangular, can also be like square. So AC may have any form. So it is not really important that AC should be always like in the sinusoidal waveform. But one thing is to note that there is a theorem called Fourier's theorem, applying which we can convert this triangular, square or any other waveform into a summation of some sinusoidal waveform with different frequency and amplitude. So for this moment it is sufficient to understand the AC as sinusoidal waveform. Now, sinusoidal waveform is written as I equal to I0 sin omega t with a phase phi. Now it can also be written as I equal to I0 cos omega t plus phi. Actually, there is no difference between sine and cos function. Actually, there is a phase difference of pi by 2 and that's all. Sinusoidal function and cosine function are same. Now, we'll try to understand some basic definitions. So first, we'll go with frequency, that is N, or sometimes it is called F. Now what is N? N is basically number of complete oscillation in 1 second. So if there is n number of oscillations and the time taken for n number of oscillation is t, so small n equal to n by t. Now there is another definition which is angular frequency. If we multiply n with 2 pi, we get angular frequency. And there is another definition which is called time period. So time period is actually inverse of n, and the definition of time period is actually the time taken for one complete oscillation is called time period. Now we can prove these relations easily. So the proof of this relation is left for you. If you are unable to prove these little relations, I'll help you, but for this moment I'm not giving the explanation that how we can prove t equal to 1 by n and omega equal to 2 pi n or omega equal to 2 pi by t or t equal to 2 pi by omega. These relations are really important for mathematical purpose. I mean, whenever we will be trying to solve some numerical problem, it is really important to remember this relation. Now we'll try to calculate the average value IAV, which is equal to 1 by t 0 to t. So this is really important that whenever we're trying to calculate some average value, the way of calculating the average value will be taking 0 to t integration 0 to t 1 by t. So this is a point to be noted down. So here it will be I0 sine omega t dt. Here we have taken theta to be equal to 0. I0 t 0 to t sine omega t dt. So I0 minus cos omega t 0 to t I0 2 pi, because t equal to 2 pi by omega, so omega t equal to 2 pi, so it is equal to cos 2 pi minus cos 0, that is equal to actually 0. Now we will try to study the mean value for t by 2. So IAV t by 2 equal to, so as I said in my previous deduction, that 0 to t 1 by t. So whenever we are trying to at that time we was trying to calculate the average value for the total time period. So now we'll try to calculate the average value for half time period. So it will be t by 2 0 to t by 2 I0 sine omega t dt. Sorry, there will be theta plus theta dt. So as I0 constant, this is actually the amplitude, so this is a constant quantity, t by 2 sine omega t plus theta dt I0 t by 2 omega 0 to t by 2, sorry, we can I0 omega t by 2 cos omega t plus theta 0 to t by 2. Now we will put this value here first and then the value 0. So I0 pi cos omega t by 2 plus phi minus cos phi. Now if we take phi equal to 0, that means our wave function is sinusoidal. So I average t by 2 equal to I0 by 2 I0 by pi cos pi minus cos 0. Actually we have forgotten one thing. There will be a minus quantity here. I0 by pi. So I average t by 2 equal to 2I0 by pi. Now we will calculate RMS value. So this is IRMS. So what does RMS value means? It means actually root mean square value. So in order to calculate the RMS value of current, we will first square the term, that is I0 sine omega t. So we'll square the term, then we'll calculate the mean. Now as I have said, we can calculate the mean by taking 0 to t 1 by t dt. So this is really important to remember, as I am saying again and again, 0 to t 1 by t dt. So this is really important, 0 to t 1 by t dt. Now this is the mean. Now we'll calculate the root. So root means simple. We'll calculate the root of the entire term. So we can write I square RMS equal to 0 to t 1 by t I square sine omega t dt. Now as I0 is a constant quantity, 0 to t sine square omega t dt. Now we will use cos 2 theta equal to 1 minus 2 sine square theta. So this is equal to actually I0 square by t 0 to t, it's half, and 1 minus cos 2 omega t dt. Now this is equal to sine 0 square by 2t. Integrating the entire term, we get t minus cos 2 omega t minus 0 plus, sorry, it will be sine 2 omega t, it will be sine 0. So both of these terms equal to 0. I0 square by 2t t equal to I0 square by 2. So RMS equal to I0 square I0 by root 2. So this is really important formula to calculate the IRMS from the maximum value of the current. We'll just divide it with root 2 and we get the RMS value.